Welcome to my channel! Learn with Teacher Ali!
Matatag Curriculum, Science Grade 4, Quarter 3, Week 2. And our topic are about force exerted by a magnet or force at a distance and properties of a magnet. Content standards. The learners learn that number 1, science processes help in observing and predicting how things move. Number 2, pushes and pulls can change the position and shape of objects. Number 3, gathering scientific information helps explain the behavior of objects and materials. Number 4, magnets affect some objects and materials without touching them. And number 5, energy is present whenever there is movement, sound, light, or heat. Performance standards. By the end of the quarter, learners use simple equipment and processes to measure and record data related to movement and describe and predict the way things around them move using more scientifically technical language and concepts, such as speed and force. They demonstrate an understanding that science processes are used to gain a deeper understanding about forces that cannot be seen directly, including the properties of magnets. And for learning competencies, the learners identify example of how object can affect other objects even when they are not in contact with each other, such as magnets attracting other objects. And the learners carry out guided investigation to identify the properties of magnets, including how they affect other magnets and objects made of different materials. Let's start! Day 1. Let's have a think, pair, share activity. Instruct the student to think about the following questions and make individual written responses in their science notebook. After writing their responses, they will share their answer with their seatmates. Number 1. When force is applied, does it always require contact between two objects involved? And number 2. Is it possible for us to push or pull an object without touching it? Explain your answer. Read the listed learning targets below. Instruct the student to assess themselves to see if they have developed these skills already and rate themselves according to the guide below. They write their ratings in the column before learning the lesson. After learning the lesson, we will go back to this. Using your homework, define the following terms. Here are the answer. Number 1, magnets. A magnet is a natural rock or a metal object capable of attracting specific types of metal towards it. Number 2, repel is to force something to move away. And attract is to pull something toward another thing. While demagnetization is the reduction or complete removal of a material's magnetic properties. Now, students, is it possible to push or pull an object without touching it? Did you know that the Earth is a large magnet? Remember that the Earth possesses a magnetic north and magnetic south, with invisible lines of magnetic force extending from the north to the south. Discuss with the student what magnets are and their basic properties, such as having poles like north and south, the ability to attract certain materials, and the concept of repulsion between like poles. Take note also that force can be exerted without touching an object, like the force exerted by a magnet. Magnets attract materials made of iron, nickel, and cobalt. Materials that do not contain these metals are non-magnetic, like wood, plastic, cloth, etc. The strength of magnets varies. Its strength is determined based on its size and the number of its tiny magnets, like magnetic domains that are aligned. Magnets have two poles, the north and the south poles. Similar poles repel while opposite poles attract. Magnets can lose their magnetism over time, which is called demagnetization. However, this process typically occurs very slowly, and in many cases, magnets can retain their magnetic properties for years or even decades without significant loss. The rate of demagnetization depends on various factors, including the material composition of the magnet, exposure to high temperatures, physical damage, and exposure to strong external magnetic fields. If you cut a permanent magnet in half along its axis, each half will typically retain its magnetic properties and behave as a smaller magnet. However, the strength of each resulting magnet may be slightly weaker than the original due to the cutting process and potential damage to the materials. Many objects used in our daily lives contain magnets, like speakers, cell phones, magnetic locks of bags and wallets, and refrigerator magnets, among others. Now let us answer the following. Number 1. Do you have an object with you right now or at home that has a magnet? What is it used for? Number 2. How does a magnet affect other objects? And number 3. What kinds of objects are attracted to a magnet? Below are statements about magnets. On the column before the statements, put a check mark if you agree with the statement and an X if otherwise. Do not answer the column after the statements. Below are statement about magnets. On the column after statements, put a check mark if you agree with the statement and an X if otherwise. Compare your answer with your previous response. True or false? Carefully read the statement below. Write true if the statement is true. Otherwise, write false on the blank space before each number. Day 2. Student, what is force? Have you tried using a magnet? It is amazing how a magnet works. It has a lot of uses which can be very helpful in our daily lives. Do you know that many electrical appliances use magnets? Like mobile phone, speakers, and stereo sets have magnets to help them produce sounds. Appliances such as refrigerator, blender, and washing machine have parts that make use of magnets. The door of the refrigerator contains magnet strips called magnetic gaskets. Now read the poem about magnet and answer the question that follow. Number 1. What are the things mentioned in the poem that are attracted by a magnet? Number 2. What do you think is the reason that made these things attracted to a magnet? Now let us read the story about Magnet Max. There once was a boy named Magnet Max who wanted to test what magnets attract. He loved to explore with objects galore to see what kinds of things would react. One sunny day, Magnet Max went to play at Nick's house. Max showed him the habit of his wonderful magnet. Watching it work blew Nick's mind. "Wow!" Nick yelled. "That's well!" The magnet's power gave him a thrill. Magnet Max made no reply. With the wink of an eye, he made his magnet attract at his wheel. Nick leaped up with glee at the magic. "You see, and us, how do you get them to stick?" "Magnets give off a magnetic field," Max replied. "They stick to anything like iron or steel real quick." If you please, even nickel and cobalt can be attracted with ease. There are so many possibilities. These are metals that can be part of many things such as ring, and being magnetic is key. So on that day, the boys decided to play by searching for things they could find. They looked for metal objects all about, in and out, and found many things: a paper clip, the refrigerator, a nail, and a bolt were attracted to the magnet with force. Nick exclaimed, "Goodness sakes, I'm amazed at the magic it makes. Can we get it to stick to a horse?" But a shoe, a ball, a plant, and a doll could not stick to the magnet, of course. "These items are not magnetic or kinetic," said Max. "They don't have the special force." The day had gone by as they searched far and wide in the house for more objects to test. They heard Nick's mom call from way down the hall. "Max, your mom say it's time to go to rest." Max and Nick said, "Oh, man. We just began. We aren't done. We were just about to test out a comb." They both looked at the magnet, wanting more to explore. It was time for Max to go home. Then Max said, "How about we hang out tomorrow and we can continue our play?" As Nick walked home, he thought of what they suggested and tested and how fun it was to explore today. Max wanted to share his tool, and that's so cool so the other kids could feel the same joy. He lay down in bed to relax. Then closing his eyes, he dreamed of how wise he would be as the explorer, Magnet Max. Now let us answer the following. Number 1. Who are the characters? What did they do to magnets? Number 2. How do magnets affect other objects? And number 3. What kind of objects are attracted to a magnet? Now let's have an activity. Will it attract? They are presented with pictures of magnetic and non-magnetic objects. They will draw a line from the magnet to the things it will attract. Now let us answer the following. Which objects are attracted to the magnet? Why? Which objects are not attracted to the magnet, and why? How do you decide which materials belong to the group that is attracted to the magnets and which ones did not? Students, can you think of any real-world applications where understanding which materials are attracted to magnets is important? Day 3. Copy the giant magnet and the boxes in your notebook. Then write inside the boxes the names of the object it can pick up. Now, identify what is being referred to the following statements. Choose your answer inside the box. Write your answers on a separate sheet of paper. Number 1, it is the force exerted by a magnet. Number 2, it is a magnet that is mined from the earth. Number 3, it is something that attracts iron. Number 4, It is the power of a magnet to attract iron. Number 5. It is the space where magnetic forces work. Number 6. These are common artificial magnets that keep their magnetism for a long time. Number 7. These are magnets that are made or manufactured by man. Number 8. These are artificial magnets that are cylindrical and rectangular. Number 9. These materials are not attracted towards a magnet. And number 10. These materials or substances are attracted towards a magnet. Match column A with the correct answer in column B. Write your answers on a separate sheet of paper. Now let's have an activity. It is called Magnet Treasure Hunt. This is by determining the object if it is magnetic or non-magnetic. Number 1. Divide the students into small groups or pairs and provide each group with a bar magnet or any available magnet, a container of objects, and a worksheet for recording observations. And number 2, instruct the students to use the magnet to explore the objects in their container. They should test each object to determine whether it is magnetic or non-magnetic. They should categorize the objects into magnetic and non-magnetic. Here are some of the process questions. Revisit the self-assessment checklist used at the start of this week. Ask your student to write their self-assessment ratings using the scale below in the third column of the table below. Multiple choice. Carefully read the questions below. Choose the correct answer from the choices below each question and circle the letter corresponding to the correct answer. Day 4. Place a magnet on either side of each object listed below. Write yes if the magnet attracts the object, or no if it does not. Write your answer on a separate sheet of paper. Write CF if the statement is contact force or NCF if non-contact force. Write your answers on a separate sheet of paper. Write M if the following objects contain magnet or NM if they do not. Write your answer on a separate sheet of paper. Students, remember that magnets exert a force of attraction on materials containing iron, steel, nickel, or cobalt. Additionally, magnets can draw other rigid magnets closer or push them away or repel. This happens because of magnets' two contrasting ends or poles, a north pole and a south pole. North poles are drawn to the south poles of other magnets while they repel other north poles, and south pole exhibit similar behavior, attracting north poles and repelling other south poles. Students will explore how magnets react with other magnets. Before conducting the activity, They must predict what will happen if the magnet's poles are placed next to each other. Conduct the activities given in the table below to observe how magnets behave. Write your observation and illustrate what you observe. Use arrows to indicate if magnets pull or push each other away. Explore further by moving the magnets closer or farther from each other. What are the characteristics of objects attracted to the magnet? What about ones not attracted to the magnet? What have you observed when you move the magnet closer or away from each other? And for last question, what conclusion can you draw about magnets based on this activity? Good job, everyone! Thank you for listening. End of week 2.
Thank you for watching! Also, don't forget to like, share, subscribe, and click the notification bell for you to be updated on our latest videos. See you on our next lesson. Goodbye!